Hi, DS friends. It's Chris and Anthony, and we're back for part two of the question and answer session. Now, these questions and answers are listed on the left-hand side of your web page, but we wanted to talk through and provide a little bit more, oral kind of feedback on these questions and answers. The next question, moving on down, that's displayed here on the screen is how you differentiate content and instruction. Wow, is this a big question? And it's not one that just applies to math, for goodness sake. I'm sure it's something that challenges us and no matter what we do. So um, we've just listed a couple of different ways that you might differentiate instruction. Now, one of the ways we differentiate instruction is we do it in small groups. We can do that through pullout when an interventionist supports you. We can do that during a lesson itself while other kids are working more independently or in their small groups. You, the teacher, can pull a small group to provide more support. We do that in English language arts very frequently. What I'd like to kind of share with y'all right now is whole group differentiation. So basically, what are some practices that you can employ when you're teaching the I do it phase of a lesson or the we do it together phase of a lesson? Well, one thing you can do to differentiate is to teach prerequisite skills. So if you have determined or if you have inferred that kids are going to need some support on a skill that's prerequisite to the standard, then spend time doing that. That's a way of differentiating our content. The next way is known as the concrete representational abstract model. I like to call it the 3D, 2D symbolic. And so here's a big goal for us, y'all. Every time we introduce a concept, let's first try to do it three-dimensionally, using a concrete object or a realia. Then let's show that same concept 2D, and finally using symbols or terminology that's math specific. That's where we do want to get kids. The way I would describe that in words is listed. I'm going to come up with a different way. You can read about how you could model fractions, 3D, 2D, and symbolic, but let's think of other ways you could do it. How about when you're solving a one-step equation? So x plus 3 equals 7. Well, many of y'all are familiar with algebra tiles or algebra balances, but simply stated, you can use an object to represent the variable. Let's say that object is a water bottle. And then you can use, let's say, cubes, red cubes, to represent plus 3. And then you can represent the equal sign with, with an equal sign, or with one side of a balance, or many other things that represent kind of this break between one side of the equation and the other. And then, of course, you can use the same representation, cubes, let's say, the same colored cubes, to represent 7 in my x plus 3 equals 7. And then you can concrete, three-dimensionally, show what it means to determine the value of the variable, what it means to subtract, in my problem example, 3 from both sides. Well, if I take 3 away from this side, the only way this equation is going to stay equal is if I take 3 away from the other. Now all I have left is this water bottle that represented my variable, and all I have on the other side of the equation is 4 cubes. Next, in 2D, you just want to transfer that type of thinking into a picture that you would draw on a smartboard or a whiteboard. So you might still be using figures or images, but now you're doing it in a two-dimensional frame. And then lastly, you just convert that into symbols themselves. X plus 3 equals 7. Another big goal for us, y'all, is to use always and whenever we can the 3 primary modalities to help kids understand things. So auditory, visual, and kinesthetic. Kinesthetic is also known as TPR, or total physical response, particularly helpful with our English learners. And all that means is that you don't just want to say what you're trying to have students understand. You also want to reinforce that visually, and whenever you can, you want to reinforce it through some physical movement. And I know we do this already. We have human number lines, or many other things. We have students demonstrate an acute angle with their 2 arms, or an obtuse angle with their 2 arms, or a right angle with their 2 arms. So whenever we can involve all 3 of those, our students are going to be the better for it. Another way of differentiating instruction is to provide steps, and this is something that we've modeled in our anchor lessons. You guys, this might seem a little weird to you because as adults, we kind of know how to solve the problems. And we want kids to get to a point where it's very authentic, very seamless, very problem solving. But initially, heuristics or steps are really important for kids. So let's provide those in initial phases. And I've talked a little bit more about that during the lesson planning video, but you just want to really slow your thinking down when you're solving a problem that you're going to ask the kids to solve, when you're going to teach the kids to solve, and just try to record that slowed down thinking that you go through into steps, and then share those with kids. Maybe even build steps with your kids. But do provide them with sort of a logical flow that they can use, particularly early on when they're learning to do something new. Another way of differentiating is to use visuals whenever possible. And guys, there are so many different ways you can use visuals. And in fact, the Common Core standards require us to use visuals to do things like multiply fractions. So that's going to be part of our learning as teachers, is how in the world do we do that? The one I want to share with you guys is called the BAR model. And the BAR model comes out of Singapore math, and it's just the best thing ever. You can use it from kindergarten through algebra. And I'm not going to go through these with you because it takes some time to read through them and kind of understand. But as you can see on this document, the BAR model is shown from simple addition through subtraction, through algebraic types of problems that involve fractions even. So the BAR model is wonderful. There are other strategies that we can use with kids, particularly when they're solving word problems, that we'll work on together, but I think the BAR model is one that will really serve them well for years and years. The point is, let's try to make mathematics visual whenever we can. That's a great way of differentiating. A couple other quick questions and answers. What if I want to add content to the block? What I would say to that is, if the content is from another Common Core state standard, excuse me, if the content you want to add to, let's say, block 2 is from block 5, but it is a Common Core state standard, then sure, particularly if it integrates nicely. Here's an example. I'm adding in the early grades. Let's say I'm adding whole numbers. And I like to show adding of whole numbers using a ruler, using measurement. Well, measurement comes up in block 6, but I'm in block 2. Well, you bet. Do inject that Common Core state standard content. It makes sense. Now, the caution is your goal in each of the blocks is for students to demonstrate mastery of the content in that block. So what we don't want to do is rush. What we don't want to do is sacrifice depth and complexity so we get through stuff faster. So be cautious. A related question is, can I teach the content that is not a Common Core standard? And I would really ask you not to do that. So you think it's really important for third graders to know blank. Well, if we all got in a room and had that discussion, we'd have a really long list. In fact, that's what happened when the Illinois Learning Standards were created. We don't want to go back to that. Less is more. We have had a problem for decades in mathematics in this country of having content and a curriculum that's a mile wide and an inch deep. We have to stop. We have to make it less wide and deeper. So please don't inject new content that is not a Common Core standard. The Common Core standards are aligned vertically. There is a document on the left-hand side of your math maps that show you how this content flows from grade to grade to grade to grade. And we can get our kids there, and it's really going to benefit them. So please don't add new content that's not a Common Core standard. Going back up, can you teach the standards within the block out of order? In other words, number base 10, 1, 2, 3, and 4 are represented in the first block of your grade level. You want to do number base 10, 3 concepts before. You bet. You might find that you're reordering how standards are sequenced in a block. You might find that you're really, in a given days or a couple of days worth of instruction, that you're really addressing more than one standard, and that's just fine. Really let this Common Formative Assessment, the CFA, and your students' needs guide what you're doing. But teaching standards out of order within a block, you betcha. Last question, can I move on early if students have mastered a block's content? And this is similar to the question of what if I want to add Common Core standard content to a block. You know, you can move on early if you really feel that your students are really ready to master content, but ask yourself why. Now, if you're doing it because, you know what, I think this next block is really going to require some extra days and I think I have them, well, that makes sense. But if it's just because you've covered everything, well, then I would use caution and go back and get to greater levels of depth and complexity with the current block's content. Allowing kids who still need a little bit more time and some different strategies, allow them that time. So just use a lot of caution. We certainly don't want to race through, nor do we need to race through this content. It's sensibly paced across 8 blocks. All right, folks. I suspect that our question and answer document will grow throughout the year, so we might have to make a part 3. But this concludes part 2. By the way, I can tell you that when we started this process several months ago, we only had a part 1. So thank you for your good questions and keep them coming. As always, Anthony Claypool and Chris Weber are easy to find on Google email using our Distinctive Schools accounts. Don't hesitate to email us. And again, I'm on campuses 1 full day, twice a month to talk about these types of questions or to do with you. I'd love to teach, I'd love to plan, I'd love to analyze data, whatever it is that you think would be most helpful for you and your kids, I'd love to do it.